Hi Math 1 students, today we're going to continue in Module 8. This is basically task 8.3. I'm calling it Identifying Polygons on a Coordinate Plane. We're going to go through, you can take notes or you can just simply follow along with the notes, and then you'll have homework pages to try based on some of the stuff we've done in these notes. So part 1, some background material we need to recall. When we worked in Module 6 and 7, we studied regular polygons and special quadrilaterals. So some of the properties we had, if you recall, a regular polygon is a polygon with all congruent sides and all congruent angles. They're all the same. Some examples of regular polygons are, how about equilateral, which means equal sides, equilateral triangles, if you remember that. So a triangle that has all three sides that are the same length. And the other very common one is a square. And of course a square, we all know a square. A square has 4 congruent sides. It also has 4 right angles. Oh, by the way, the equilateral triangle, all 3 of these angles are the same, and they're all 60 degrees. Anyway, another special triangle that we learned about is the Isosceles Triangle, Isosceles Triangle, which usually has 2 congruent sides. It can also have 3 congruent sides like this. This is technically an Isosceles Triangle, but usually in an Isosceles Triangle, we're just talking about 2 congruent sides. And of course, if you remember the theorem, if you have 2 congruent sides, you have 2 congruent angles. But in this particular task, all we really care about is the side lengths of these. The other thing that we studied in detail was a special set of quadrilaterals. And by the way, quadrilaterals are 4-sided polygons. And these special quadrilaterals that we studied were, the whole group was called parallelograms. And by definition, parallelograms have 2 pairs of parallel sides. So we had 4 different types of parallelograms that we studied, actually 6, but mainly the basic parallelogram, a rectangle, rhombus, a square, and then 2 other oh no, they're not parallelograms. 2 other shapes that are quadrilaterals that we studied are the trapezoid and kite. So we'll look at those properties too. Let's list the properties that are important for each of these parallelograms. Now, ultimately what we're going to be trying to do is to look at a shape on a coordinate plane, use the ordered pairs that are at each vertex, and get the side lengths, get the slopes of the sides, and determine which shape that we're dealing with. So in a parallelogram, just by definition, has opposite sides are parallel. Both pairs of opposite sides are parallel. And that's basically, you know, what we need to know that's important for a parallelogram. Opposite sides are also congruent. Sorry, I forgot that thing. So we need both of those. And there we have a parallelogram. Now, another type of parallelogram is a rectangle. So what else do we know about a parallelogram that makes it a rectangle? And you have to think about that parallelogram, instead of being slanted edges, it's going to straighten up. That's the way I like to think of it. So it has all of the features of a parallelogram, plus it has 4 right angles. And of course the right angles, 90-degree angles. Now there's a lot of other properties that we learned about a rectangle. You know, we learned about the diagonals, same with a parallelogram, diagonals and all that kind of stuff. But if we're looking to prove that we have rectangles, rhombuses, squares, or what have you, we actually don't have to study all the diagonals. We can just look at the sides and the angles, which will involve knowing about the slopes of the sides. All right, in a rectangle, let's add one other thing here. This is parallelogram properties plus 4 right angles. In a rhombus, we have parallelogram properties plus 4 congruent sides. So opposite sides are parallel, opposite sides are congruent, but all 4 sides are congruent, not just opposite sides. Okay, so that's what makes a rhombus special. The other thing we actually, rhombus, if we just draw one real quick here, bad drawing, but the rhombus, the diagonals are also perpendicular to each other. In a rectangle, the diagonals are not perpendicular to each other, but they are congruent. These are not congruent, these are congruent. So there's other ways that you could differentiate between a rhombus and a rectangle, but mainly we need to know about the sides. Alright, a square, and we can remember a square is a parallelogram, it's a rectangle, and it's a rhombus all at once. So it has all the properties of a parallelogram, plus the properties of a rectangle, which is 4 right angles, plus the property of a rhombus, which is 4 congruent sides. And there is our special shape, the square. Okay, we'll come back to these properties in a minute, but those are the basic things that we need to think about. 2 other shapes that are important to know, the trapezoid, which I talked about a minute ago, and a kite. So if we just sketch this piece right here, remember a trapezoid has 1 pair of parallel sides instead of 2. So we could say only 1 pair of parallel sides. And nothing else has to match at all. No other side lengths need to match at all. It just has to have 1 pair of parallel sides. And it has to be a quadrilateral. The kite, a little more special than the trapezoid. The kite, in a way, looks like a rhombus, but it has, it does have perpendicular diagonals, but it has 2 adjacent sides that are congruent, and another set of 2 adjacent sides that are congruent, but different lengths than the first pair. Okay, so 2 pairs of adjacent, and adjacent means right next to each other, so they're right next to each other. 2 pairs of adjacent congruent sides. And a few other things, but that's the main thing we're interested in. So here on the next page, I'm going to practice a little bit with using, this is a kite, so we're going to use what we learned in last week and the week before, kind of about slope and parallel and perpendicular lines and congruent segments, to make statements about the segments in this kite. And what we're basically going to do, we're going to complete the mathematical statements here with a mathematical symbol that relates these. So they'll either be congruent segments or triangles, as the case may be, perpendicular, parallel, less than, greater than, or equal to. And we're going to prove each statement algebraically. And what that means is we're going to show the slope when that's appropriate. We're going to show the length mathematically that we calculate. And then we're going to compare different lengths or different slopes to determine what statement needs to go in here. So the proof is then, like if it ever says like explain how you know, or show justification for your answer, or prove your answer, that means it wants algebraic statements that show that these things are true. Now, this says that it's a kite. We already know certain properties of a kite, so what we're going to do is we're going to look at the segments that it's asking about, and we're going to kind of predetermine whether we want to know if they are congruent or parallel based on their relationship here. So this first thing says segment BC. Let's see where that is. BC. BC is this segment down here. And we would need to compare that to segment DC. Okay, now obviously this is not a parallelogram, so we don't need to show that those slopes are the same or different. We're basically looking to see what the lengths of these 2 sides are. So let's take a look at that. We're going to need the distance formula for this one. Actually, I'm going to do this easy one first. This goes up to a y value of 5. It's not marked on the scale, but it's still a y value of 5. I can tell by that. And so this distance from 5 all the way down to 0 just has to be 5. So DC equals 5. I'm actually going to jot that down right below DC. I don't have to show anything else mathematically. I just counted that. on this other one, I'm going to need to figure out the distance between the point 0, 3 and this point, which is not labeled, but I could write the label. It is 4, 0. And I need the distance there. And I'm hoping it's equal to 5. Now, a couple ways you can do this, if you remember. I can just make a right triangle from this and look at the distance here and here, and then do the Pythagorean theorem. Or I can do the distance formula. Let's do the Pythagorean theorem for this one. It's kind of neatly set up. So in this one, this goes up to y equals 3. It starts at 0 to 3, so this has a height of 3. From 0 to 4 is a length of 4. So basically our triangle has a side of 3 and a 4, and we're trying to find out what the hypotenuse is. So if we put together the Pythagorean theorem there, we have 3 squared plus 4 squared equals, and I'm going to just write it as BC squared. BC is the segment length we're after. So we have 9 plus 16 equals BC squared. If I take the square root of both sides, that gives me BC equals square root of 25, which is 5. So I have 5 there, and that shows me that these are actually congruent. Now we don't want to show equal there. 5 equals 5, but a segment is congruent to another segment. You don't want to use an equal sign when you're using segments. That's basically how this is going to work. So let's try to go through the rest of these. I'm going to pick up the pace a little bit though. Alright, here's our next one. BD, which is the length all the way across here, and we're going to compare that to the length AC. These are the two diagonals, so we have two diagonals of a kite, and we should not expect these two things to be equal. If they were equal, then maybe we would have a shape that was not a kite, and it would be it would have to be a rectangle or something like that. Anyway, so let's look at these lengths. So BD, I'm going to use the distance formula for BD. So remember the distance formula is the square root of the difference in the y values squared, and then the difference of the x values squared. So the difference of the y values, I have a 3 and a 5. The difference of 3 and 5 is 2. Don't forget to square it. And then the difference in the x values, I have an x value of 0 and x value of 4. The difference between 0 and 4 is 4. It doesn't matter what direction it is. I don't have to say negative 4 or positive 4. The difference is just 4, and the difference here is just 2. So I have the square root of 4 plus 16, or the square root of 20. That's what BD is. Now I'm going to leave it just like that. The next length I need is AC. So AC, using my distance formula again, my points are 1, 6, and 4, 0. The difference in the y values, the difference between 6 and 0 is just 6. Square it. The difference in the x values, I have an x value of 1 and an x value of 4. The difference between 1 and 4 is 3. So that's going to be 3 squared. So I got the square root of 36 plus 9, which is the square root of 45. Now, I don't even need to do this in my calculator. I can obviously tell these are not going to be the same answer. So I'm going to say that these are not equal or not congruent. And they didn't give me a symbol choice here, but here's what you can do. You put the symbol congruent and then put a line through it. It shows it is not congruent. Okay, the next one is to compare the AB to BC. AB is here. BC is down here. Again, this is not something we're trying to compare slope on. Let's just look at the lengths. The length of BC we already have. We don't need to show that work again. BC is equal to 5. We already know that. And I need to calculate AB. I'm going to use the distance formula again. A is up here, B is there. The difference between the y values. The y values are 6 and 3. The difference in 6 and 3 is 3. Square it. The difference in the x values is 1 squared. So I have the square root of 9 plus 1, which is the square root of 10. So these two are obviously not equal. We'll put not congruent. We're going to actually look at the slopes on this next video.